Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of logarithms. And if I talk about the question which is given to us here from this topic, the question tells us that equation is given which is log of cot x to the base cos x plus 4 times log of tan x to the base sin x is equal to 1, where we have been told that x goes from 0 to pi by 2. So x is in the first quadrant. Further, we have been told that the solution of this equation which is there, that solution is sine inverse of alpha plus root beta upon 2. Further, we have been told where alpha and beta are some integer values, and we have been asked to find the value of alpha plus beta here. And if you see the option that are given to us, the first option is given to us as 3, second option given to us is 6, then 4, and then 5. So we need to figure out which one of the following four options is the correct answer for the expressions value that is asked to us, that is alpha plus beta. So let's try to solve this equation. We have been given log of cot x to the base cos x plus log of tan x to the base sin x, which is 4 times, that's equal to 1. So if I try to solve this further, I can write that cot x as cos x upon sin x to the base cos x plus 4 times log of tan x. I can just write that as sin x upon cos x to the base sin x is equal to 1. Once I have log of a by b, I can just use the idea log of a by b. I can just write that as log a minus log b. So I can use the logarithms idea to solve that further. So if I try to solve this further, I get this as log of cos x minus log of sin x. This is to the base cos x, and this is also to the same base cos x, plus 4 log of, we can write that as sin x to the base sin x. Again, I'm using the same idea, log of a by b, I'm writing that as log a minus log b. So log of cos x again to the base sin x. That whole thing is given equal to 1. If I try to solve this further, let's see how do we solve this. I know one more idea of logarithms. If I'm trying to use log a to the base a, it's equal to 1, right? So if I use that idea for this expression, I get this turning to become 1. So 1 minus log of sin x to the base cos x plus 4 times log of sin x to the base sin x. That whole thing is also equal to 1. So you get 4 times 1 minus, this becomes log of cos x to the base sin x. The whole thing equal to 1. So if I try to solve this further, let's see how do we solve this. So I get this 1 minus log of sin x to the base cos x plus 4 minus 4 log of cos x to the base sin x, that is equal to 1. So if I take that 1 on the other side, it becomes 1 minus 1, which is 0. So you would be left with 4 minus this entire idea, log of sin x to the base cos x. So I can again use one more idea here, that is the property of logarithms. Log a to the base b, I can write that as log a upon log. So if I use that idea again for this question, this expression becomes log of sin x upon log of cos x, and I'm just cancelling this 1 and 1 because 1 minus 1 would become 0. So you get 4, which I have written here. Then you have this, I have written like this, minus, I can again write this as 4 log of cos x upon sin x. That is equal to 0. So if I take both of these ideas on the other side, you get 4. It's equal to log of sin x to the base cos x. Again, I'm writing this as it is. But if I see this, it goes on the other side. So first it becomes plus 4. And I can write this entire expression as of upon log of sine x upon log of cos x. So if I'm writing it as log of sin x upon log of cos x, that is in the form of log of a upon log of b, I can write that as log of a to the base b. So now my denominator, I can write that entire thing again as log of sin x to the base cos x. So instead of this entire expression, I can write this as like this. Now if I write this as it is, if I write it in the other step, 4 is equal to, we had this as log of sin x to the base cos x plus 4. We had this further as log of sin x to the base cos x. Now once I have the entire expression same in both of these ideas, both of the terms, I can just substitute this entire thing. So I'll put log of sin x to the base cos x is equal to t. So I'm substituting log of sin x to the base cos x equal to t. So if I do that substitution, I get 4 is equal to t plus 4 by t. So if I solve this further, I get the expression turning out 4t is equal to t square plus 4. If I try to solve this further, I get t square minus 4t plus 4 is equal to 0. Solving this quadratic equation, I can write this entire expression in the form of t minus 2 the whole square equal to 0. If I try to solve it further, I get t as 2. So both of the values for t is 2. So I get the value for t, that is 2. Again, once I get the value for t, I am again resubstituting that t. So we substituted log of sin x to the base cos x equal to t. So I am resubstituting t as log of sin x to the base cos x. So from this idea, I get this entire thing. T was equal to 2. So from this idea, I get log of sin x to the base cos x is equal to 2. Further, if I have log of a to the base b, again I can use the idea which we already discussed previously. I can write that as log of a upon log of b is equal to 2. So I'm just using this idea again. Log of a to the base b is log of a upon log of a. Further, in the next step, if I try to solve this, I get it as log of sin x, it's equal to 2 times log of cos x. So if I take this 2 on the other side, I get log of sin x. It is equal to log of cos x the whole square. When you have, again, if I use the other property of logarithms, if you have log of a equal to log of b, I can write log, or instead I can remove the log and I can write a equal to b. So if I use that idea, I get this sin x equal to cos square x. Sin x is equal to cos square x. If I further solve it using the identity, I can write that as 1 minus sin square x. I'm using the identity that says sin square theta plus cos square theta is equal to 1. So from this idea, I get cos square theta as 1 minus sin square. Further, once I get this entire idea, I can further solve it. You get this sin square x plus sin x minus 1 is equal to 0. You have this entire expression written now. So I can write sin square x plus sin x and plus 1 if it goes on the other side becomes minus 1. If I try to solve this idea using the general form of quadratic equation ax square plus bx plus c equal to 0, where we have instead of x sin x and a is 1, b is 1, c is minus 1. So with that, if I apply the formula method to find my values, I get the roots of the quadratic equation, that is sin x is equal to minus b. So if I am applying the idea, we know quadratic equation x is minus b plus minus root of b square minus 4ac upon a. So if you apply the idea minus b, so minus 1 plus minus root of b square, so 1 square minus 4a and c upon 2a. So you get these values of sine x turning to become -1 plus minus root of 1 minus of -4, so 1 plus 4, that is 5, upon you have 2. So you get this entire expression of sine x, and that was the answer which was asked to us. So we get the solution of the equation in terms of sine x. But when I have been given here, I get x as sine inverse of, because I want to find the solution of equation in terms of x. Sine of x, I get it as -1 plus minus root 5 by 2. Now, we were also told a data that said x belongs to angles between 0 to pi by 2. And when x belongs to 0 to pi by 2, that is in the first quadrant, when your x is lying, we have the values for sine theta as positive in the first quadrant. So when we have two values of sine x that were -1 plus root 5 upon 2, or we had -1 minus root 5 upon 2. So basically I have to reject this value, because sine of x, where x lies between 0 to pi by 2, the value of sine theta won't be negative, because in the first quadrant sine theta is positive. So we have only one answer that is satisfying the value for sine x, that is -1 plus root 5 by 2. So if I find the value of x with that, I get sine inverse of -1 plus root 5. So that is your solution of the equation which was given to us. And we were told in the question that the solution of the equation is in terms of sine inverse of, let's see that what was the solution given. So solution was given to us as sine inverse of alpha plus root beta upon 2, where alpha beta are integers. So if I compare it with alpha plus root beta upon 2, I can compare the two ideas as the solutions, and we get here alpha is equal to -1, beta is equal to 4. Once I have alpha, once I have beta with me, if I just add both of them, -1 plus 5, that is 4. So we get the answer for the question that alpha plus beta, the value for that is 4. And if you see the option that matches here with the question, that is option S. So C is the correct answer for the question given to us. I hope you have understood how to solve this type of questions. So we just used some 3-4 properties of logarithms. One was log of a by b, which is log a minus log b. Then we use the other idea of change of base, that is log of a to the base b. I can write that as log of a upon log of b. So that we converted our entire equation in terms of one expression, that was log of sine x to the base 6. Once we got that, we put that as t, we got a quadratic equation, we solved that, we got the values of t as 2. We resubstituted t as log of sine x to the base cos x. And further, after solving that value for sine x, we again got a quadratic equation in terms of sine x that gave us, by the formula method, two values of sine x. We rejected one value of sine x because in the first quadrant we were given the values of x, and sine theta or sine x won't be negative. So we rejected the negative value for sine x. With that, we got positive value for sine x. Further, we solved that and compared that solution which we got for x with sine inverse of alpha plus root beta by 2, that gave us alpha as -1, beta as 5. Then we just took the sum of them and we got answer as 4. That matches with option C. So C is the correct answer for the question given to us. I hope you have understood how to solve this type of questions on logarithms. I will see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains as well as 11th and 12th. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of the questions on JEE. Thank you.